Straight vegetable oil, or SVO, can actually be used as fuel in diesel engines. Yup, the same oil in your kitchen cupboard. Here's the scoop. SVO is thick and needs to be heated before it can flow smoothly through your engine. Once warmed up, it's remarkably similar to diesel. Plus, using SVO can
This is my video on the Unit 5 content on the liquid biofuels for the subject called Bioenergy Conversion Technologies, which is the open elective course offered in Information Technology and Computer Science and Business Systems departments. I am going to deliver this on behalf of the faculty of Weldtech Multitech Engineering College, myself professor in Department of Mechanical Engineering. Let us dive into the main content of the slides. We are first going to talk about the straight vegetable oils as fuels. We know the diesel engines are nowadays getting blended biofuels as alternative fuels. But what will happen if we straight away use the commercially available vegetable oils, and what is the process we have to use for consideration of such a vegetable oil as a fuel? In terms of long-term operation, there is a problem with respect to the operation of the engine in an efficient way, because they will offer the performance as well as emissions only for a very short time rather than the very long period of time, because like diesel, which is a petroleum product refined particularly for the operations of the IC engines, these straight vegetable oils are not same as the biodiesel. So it is generally not recommended for long term vehicle use. We are talking here about the internal combustion engines. Let us see something more about what we can do on the schematics. If we zoom on to this, we have a schematic of the biodiesel production path. As usual, we need to take into the transesterification for the vegetable oils. We straight away take animal fat or the waste also into consideration. This will get into the form of crude biodiesel, which upon further refining, it will get into the form of the biodiesel. What exactly is additionally required is a catalyst in the form of ethanol, which is actually produced in the form of glycerin, and then the glycerin is further refined to get the methanol, and the methanol acts as the catalyst to more and more create the transesterification effect, and the crude biodiesel can be maximum converted into this so-called biodiesels. So what is the problem with respect to use of this into a biodiesel, which is straight away used here as a fuel, is we will not have the correct characteristics as designed for the specific engines. Okay, now we will see about the basic steps that are required for the biodiesel. What are the basic steps that can be required is, as it is seen in the previous slide, you have to collect those oils, even it is waste oil or the used oil. We can take that and allow any foreign particles such as the water to settle down and drain out. So this is the first process of refining it. Then making it into the catalyst tank, that is methoxide catalyst, or as we have seen in the earlier case, it can be the glycerin refined product. Then the esterification starts. The oil reacts with the methoxide to form biodiesel, and the first product is the glycerin by co-product, and the other product is the crude biodiesel. The glycerin always gets settled in the bottom because of the density difference, which can be drained off by a plug off. Next, we will see the chart of how this happens in a large scale. This commercially available forms of the biodiesels biodiesel resources in the form of biomass. We will take here the case of the castor oil seeds, and the castor oil seeds, oil has to be extracted from the seed, and then the oil is to be taken into the form of the pure oil, the preheated oil. There will be a byproduct of this as a oil cake, which can be measured to know how much of oil is extracted from the castor oil. When there is a alcohol and catalyst created, creates the transesterification effect, this will of course separate the biodiesel, and the separation of the glycerol and glycerin is happening simultaneously. The crude biodiesel is now also containing some amount of water to be added in the form of the washing agent. And finally, this washing tank is used to separate the crude biodiesel, again by means of the density difference, and by drying we get the pure biodiesel. By drying here we means the removal of the water content. So what will happen to the final form of this biodiesel is only dependent upon its properties, and it is matching to the requirements of the burning inside the combustion chamber as a fuel, then it can be straight away replaced with respect to the what already available biodiesel or the diesel being used. So as we have already seen, there is a lot of biomass need to be extracted for a smaller amount of biodiesel to be created. So even though we say it's a very straight vegetable oil, it requires refining, and since it is not created as a chemical changes, and since only the process of transesterification is into the practice, we need to see it in a mass scale level to produce only for certain types of the engines, right? So these oils can be taken into a factory level or the large scale level for operations of certain engines only. Okay. Next we will see the transesterification effect into a detailed process of what will happen when the fatty acids are less than or more than certain percentage. What we take is as a trade-off value is here 2%. The fatty acids, free fatty acids, when they are less than 22%, they can be subjected to straight away transesterification, or whenever there is a more than 2%, first esterification process has to happen, then only the transesterification process will get complete. As usual, the final addition of the water and then drying, that is removal of the water, makes the biodiesel from the straight vegetable oil easy for being considered as a fuel, which are finally collected for its which are finally checked for its physical properties. So this is another slide which is showing you on the properties of this or the detailed process of how this process is happening in the form of the transesterification. In another form, we can use the solar energy as one of the agent for accelerating the process, along with the atmospheric carbon dioxide and whatever we have as a biodiesel. Since water is also added, the water is also taken as an external agent. In an advanced process, this algal cultivation is also able to make the biomass harvesting, particularly in the case of the fourth generation of the biomass resources. And this addition of the water and removal of the water, is here called as the dewatering, and the extraction will lead to a very quick process called the biofuel production from the straight vegetable oils. Whatever the water and nutrient are recovered, they can again be resupplied to the sources, either for the cultivation of the plants or for any other process that is suitable to use it for purification or any other purpose. it's very important to see the fuel properties in comparison with the standard diesel. What we have is the standard ASTM D975 as the comparison with the biodiesel derived from the castor oil. In terms of the calorific value, it is almost able to equal to the diesel for the purified biodiesel, whereas the kinematic viscosity is more. This is a concern in terms of the fluidity of the fuel, but it can be changed with respect to the addition of the transesterification agents. The specific gravity is also very close, which makes it suitable for the injections into the combustion chambers. Then the carbon percentage is less than the amount of carbon emissions that are available in the diesel, which is a very good sign of using it in the in diesel engines in the years to come. In terms of the hydrogen, which will aid for the combustion process, it is having a self-ignition properties. As we know, this hydrogen is having very good combustion properties. The hydrogen is also helping to make the combustion process very quick, so it will also reduce on the oxygen demand also. And the next part, you will see the oxygen itself is having its component to be more when it is not at all present in the diesel. So these are all helping for the complete combustion of the biodiesel in the combustion process. When we see sulfur as a potential threat in the diesel, it is not at all present in the biodiesel, which is a very good choice when we take straight vegetable oils. In terms of the boiling point, flash point and cloud points, the flash points are very good, and then boiling points are very stable. Cloud points are very less in terms of the comparison with the diesel. The pour point is also relatively good. The C10 number is better in terms of the biodiesel than the diesel. And last, the lubricity in terms of the micrometer levels is very less. So it is almost a very good choice to go for the biodiesel when it is properly derived through the transesterification process. Finally, I want to ask few questions before winding up this session. Which is better, biodiesel or diesel? Based upon the previous slides, we can conclude very clearly that biodiesel is better in terms of the pollution control, better in terms of the combustion efficiency, and offers more benefits for the green environment. So as a comparative figure, 11% less carbon monoxide and 10% less particulate matter is released when we are using straight vegetable oils. From the resources such as Cartalk, the agricultural and Department of Energy, they found net carbon dioxide emissions to be reduced by 78%. So for continuous usage of this biodiesels based upon the straight vegetable oils, this is possible. The next question is, can you use biodiesel as a regular diesel engine? We have seen in the first slide itself, it is only used for a very short time period, and then since it is used for test level only, we need to know which kind of biodiesel is very good on this performance. A biodiesel blend is commonly used in railways also. 20% was used many years ago in place of the regular diesel. So from 6 to 20% biodiesel, if it is blended, then it is possible to regularly use the diesel engine. Okay. So with this, I conclude my short speech on this straight vegetable oils as biodiesels. I hope you have enjoyed this session. If you have any queries, you can mail me on muthukumar@welltechmultitech.org to have your queries cleared. Thank you.